Alright everybody, today I'll be going over part 2 of our review guide. These are examples that are like our review guide. They're not the actual problems on there, but they're very similar and they also relate to what will be on our test on Thursday. So we got to cover these 4 things: factoring, which we just dealt with a lot, factoring polynomials, adding, subtracting, multiplying, and dividing. So let's take a few examples of factoring, take a look at. Here's our first one, okay? Remember, we've got this order we go in. We first check to see if there's a GCF. And then if it's got 2 terms, we have all those special ones. Then it could have 3 terms. We use that RS method. And then it could have 4 terms, which we regroup and factor. Okay, there's lots of videos I've posted about those. All right, so let's take a look at this one. I check for a GCF. Okay, the first term is divisible by 2, but not the second, so I can't divide anything out of the entire problem. But it does have 4 terms, so I'm going to try to regroup it. And so remember, we just group the first 2 together. We hope this works. Sometimes we have to move things around. We group the second 2 terms together, and notice that big plus sign in the middle. Now we GCF each of these, okay, in this one group. And it looks like I can take an x squared out of both, leaving me with 2x minus 1. And I look at the second pair, and I check for them for a GCF. Looks like I can take a 3 out, leaving me 2x minus 1. Now I can see I have a common factor in each of these terms. And so I'm going to take that factor, and I'm going to pull it out front. 2x minus 1, and when I pull it out of this first term, I'm left with the x squared, and when I pull it out of the second term, I'm left with a plus 3. And so there would be the complete factorization of that expression. Next example, okay, again, I look for a GCF first. I always do that first, and these, I know 5 is, because 15 is divisible by 5. So let's see if 5 can come out. And so is 120 because it ends in a 0. So that would leave me with 3 minus 24x squared. I notice, though, that 3 and 24 are both divisible by 3. So I can take out another factor. Okay, there's no harm in not getting your GCF the first time. So I'm going to bring that 3 out now, leaving me with 1 minus 8 x squared. Like so. And 1 minus 8x, oh, this is now a 15, 3 times 5 on the outside. 1 minus 8x squared. Almost looks like a difference of squares, but I can't factor. 8's not a perfect square. Okay, I want to do the same problem. And I think this is what the problem was supposed to be. I think it was supposed to be a difference of cubes problem. So I'm going to work it this way as well, so you can see a difference of cubes worked at least. So now I know the GCF is 15, so I'll take that out right away, leaving me with 1 minus 8x cubed. And while 8 is not a perfect square, 8 is a perfect cube. And 1 is as well. This is like a 1 cubed minus a 2x cubed. So my a is 1, and my b is 2x. All right, so my final factorization, I'm going to write down the difference of cubes for you. This is, again, on your test, though, so you don't have to have it memorized. It'd be a minus b times a squared plus ab plus b squared. And so our factorization is going to be the 15, because that was our GCF, times a minus b, so 1 minus 2x. I'm going to take the 1, and I have to square it. It says a squared right here, so that's a 1 squared. That's just 1. Just 1. Then I have to take a times b, so 1 times 2x, which is just 2x. And then lastly, I have to take the 2x, and it says square that, because it says b squared, so that is plus a 4x squared. And so if it was a difference of cube problems, we'd do that. And this is how it finished when we just GCF'd it. We couldn't do any more because it was just an x squared. Next example, okay, now we have to do some addition of like terms. Okay, that's all we're doing, just adding two expressions together. Okay, and these parentheses in this case don't really mean anything. They're just grouping symbols to say, hey, I'm taking this group and adding it to this group. And that was supposed to be just a -6 there on the end. So I made that correction, and now I'll put just -6 here. Okay, and so when we are adding or simplifying by addition, we just have to add like terms or subtract them. I got 4x squareds, add 2 more on. That's a total of 6x squareds. I would do my x terms first. There's only this 5x, so it's a positive 5x. And then lastly, I've got a couple of constants, -10 minus 6. -10 take away 6 more, so -16. And there we go. We can't combine any of those after this because they are not like terms. Like terms have to have the same variable and the same exponent on that variable. Here we got a subtraction problem of two polynomials. The only thing different, again, I'm going to draw out these parentheses. The only thing different about a subtraction is you've got to subtract all these, which means distribute. Okay, and so it makes it a -6x. It's like you're multiplying everybody by -1. -6x, -5x squared, but this last one will become a positive 5. And now we'll start finding like terms. These are x squared terms. So that's 3 minus 5, that's -2x squareds. Next I would look for any x terms. There's a pair of them right there. Lost 2, lost 6 more, so I lost a total of 8 x's. And then lastly, we'll deal with our constants, -4 plus 5. So that's just going to be +1. And there we are, and I've also put it in standard form at the same time. Highest exponent, 2, then next highest, x to the first, and then no exponent. Multiplying two polynomials. This is just practicing distributing. Okay, so 2x squared times 4x squared, you take the 2 times 4, and exponents get added. I know 2 plus 2 is 4, but our 2 plus 2 is 4, and so is 2 times 2, but it's the 2 plus 2 that we're doing. Okay, and so when I distribute here, I have the 2 times -5, so that's -10. X squared times x to the first, so when I add those, that's x cubed. And then I take it times the -6. 2 times -6 is -12, and we just have an x squared. All right, let's do 3x times 4x squared. That's 12 x cubes. So, and then 3x, or 3 times -5 is -15, and x times x is x squared. And then 3 times -6 is -18 times that x. And then we got one more distributing, 1 times 4x squared. Notice I'm lining up all my like terms to make it easy. Minus 5x. And 1 times -6 is -6. And I'm just going to strike a line here and just add vertically because all my like terms are aligned. -10 plus 12, that's +2. Okay, here I've got -12 minus 15, -27, plus 4, so that's -23. X squareds, -18, take away 5 more, is -23 x's, and then -6. I don't have any like terms, and so I've multiplied those together. We got a division problem. Now this one we haven't done in a while, but notice this is a binomial, but the a value is not 1. So we cannot use synthetic division. We're going to have to use long division for this. So I'm going to set that problem up. Here's our divisor. And we're dividing that into this very long polynomial. Now we got to make sure it has all of its terms. It's got a cubic term, then an x squared term, then an x term, then a 2. So it does have all of its terms. If it was missing one, you have to put in a 0. So if it didn't have an x squared term, you'd put in 0 x squareds, just to keep everything lined up. Now remember the question we asked as we start to do this division. we just asked, what do I have to take 3x times to get a 6x cubed? Well, 3 times 2 gives me 6. I'm going to use a 2 up here. Choose a different color. And to get an x cubed, it'd have to be a x squared. Because now what we do to figure out what we're going to be subtracting is we have to distribute this. So 3x times 2x squared is 6x cubed, and 2x squared times 1 is positive 2x squared. Okay, we draw a line, put parentheses, and now we subtract. Okay, so this reads as 6x cubed minus 6x cubed. That's 0. And the next one reads 14x squareds take away 2x squareds. So that's going to leave us with 12x squareds. And then we bring down the next term. And we repeat 3x times what gives me 12x squared. So 3 times 4. So I'm going to have to use a 4 up here. And to get an x squared, I need one more x. And I distribute that to my divisor. 4 times 3 is 12, and x times x is x squared. 4x times 1 is 4x. I draw a line, and then I subtract. I get that 12x squared minus 12x squared, 0, so my x squareds are gone. And I get 7x take away 4x, so that becomes a 3x. And I bring down my 2. I ask the same question, 3x times what gives me 3x? The answer is 1. So I put a 1 up here, and I distribute the 1. Well, 1 times 3x plus 1 is just 3x plus 1. I strike my line, put parentheses, and say subtract all that. 3x minus 3x is 0. 2 minus 1 is 1. And that would be my remainder. So my answer to this division problem is a 2x squared plus 4x plus 1. Plus we usually put remainder over divisor. Like that, and that says it's completely equivalent to it. Okay, so that's long division. We haven't done that in a while. Okay, that's because all right, this is our second to last example. Okay, in this problem, they're giving us that x plus 1 is a factor of the function. So here's our function, and we know x plus 1 must divide into it evenly because it is a factor. And they want us to factor that function, factor f of x completely. So we know one factor. They told us it was. Okay, and what we want to do now is try to get factored completely. So to do this, what we're going to do is we're going to divide out the x plus 1, and that will remove one of the factors from the function. Now, fortunately, in this problem, x plus 1 is a binomial, okay, 2 terms, and the coefficient is 1, and it's x to the first power. So it's a linear binomial with a lead coefficient of 1, so we can use synthetic division. Now remember, when you do synthetic division, you want to use the opposite sign of what was in the factor. So this was the factor, x plus 1, so I use a negative 1. And now I write all my coefficients. I've got 6x cubes, 14x squareds, 7x's minus 1. Let's see if we get a 0. We should get 0. 6 comes straight down. Negative 1 times 6 is negative 6. We add negative 1 times 8 is negative 8. We add negative 1 times negative 1 is positive 1. We get 0. So at this point, you actually have f of x partially factored. F of x now factors as the factor we just divided out, the x plus 1, and then our quotient, the answer to our division problem. It was x cubed, but now it is just an x squared problem. So that's 6x squared plus 8x minus 1. And now we try to factor this guy, okay, this leftover part right there. Okay, so for this thing we're going to have to use, let's write down our A, B, and C. A equals 6, B equals 8, and C equals negative 1. Since A is a 6, we have to use the AC method. Okay, and so we're going to give ourselves a little more room here. I'm going to work off to the side. So A times C is 6 times 1, or 6. The product I'm going for is that 6, so R times S, but the sum has to be 8. So let's write down the factors. Oops, C is negative 1. Negative 1, negative 6. So we've got 1 times 6, 2 times 3, and that's it. I don't think any of these add up to 8. Now they do have to have different signs. The positive one would have to be the bigger one, so you get a positive 8, but these add up to 5, and these, while they multiply to negative 6, they only add up to 1. None of them give us the 8, and so we are completely factored at this point, and we don't have to do any more work. And our last example, this is our remainder theorem. Okay, and so we have this function, and a lot of you go, oh, I'll find the f of 2, and you use substitution, but you don't want to do that. Okay, we found out in this chapter that we could figure this out very quickly with synthetic division. 2, 4, negative 6. Bring down the 2, multiply, that's 4, 8, that's 16, that's 10. The f of 2 is 10, the remainder. I'm going to do it the old-fashioned way off to the right so you can see it works. If I want the f of 2, I'd write 2, and I'd replace my x's with 2's. That's 2 times 4 plus 8 minus 6. That's 8 plus 8 minus 6. That's 16 minus 6, and that is equal to 10 as well. Now, of these two methods, the one I want to use is this one over here because it's much quicker and much easier to do. Especially, well, this one's kind of a toss-up because it's only an x squared polynomial. But as soon as we get up to the cubes and the fourth powers, quartics, and the fifth powers, quintics, these polynomials are pretty big, and it would take quite a while to use the substitution method. That should help you get through your assignment.